now we got to get started. Okay, fifth week, 3D graphics, user interface, and 3D Max design. Okay, that's the topic for today. Here is the list for something action items for today. Today's lecture, 3D Max design, interface, and a little bit about geometric modeling from today. Okay, and also lab exercise, your requirements. Okay, 2 JPEG files, at least 5 files, one, another. But actually, we're gonna walk through lab exercise 1 through 4. Anyway, today we also review some mental ray renderers, and we're gonna get started geometric modeling. Okay, from something beginnings. Anyway, today's topic is 3D graphics and user interface. Okay, actually you have learned SketchUp or some AutoCAD or some recursive actual use in your actual design studio work. But anyway, theoretically, we need to figure out what are behind the technologies. Okay, so in terms of 3D modeling, 3D graphics, representatively, we are using this semester, this one, 3D Max. Actually, this is not kind of leading 3D software or something else. But anyway, thanks to Autodesk, it has very powerful features. That is why we are going to take advantages of using such applications. And this is kind of old version of 3D Max. As you see, I believe this type of application is most complicated user interface based application among entire applications, I think. And this is the same one, but it's 3D Max Design 2015. Okay, this one same to other general applications. This one has menu and lots of button icons. Okay. Iconic metaphors, okay? You know this teapot icon means render, okay? And this one, teapot with window, that means render setup, something like that, okay? Very iconic. The below one is so-called ribbon interface, okay? Ribbon interface provides you some grouped tapped interface, kind of dynamic. Also some optional and dynamic menu interface. And of course, this is main interface for controlling your geometry and visualization, so-called viewports. This one aims to create 3D. So usually top, front, left, 3 basic 2D views are available, and this is 3D perspective view or camera view. But actually, it doesn't matter. You can change this front view to perspective or 3D or totally different any type of views. And also main control, okay? Actually, this one has amount of tabs, and based upon your selection, this one going to be changed dramatically. In other words, too complicated. Also, there is a timeline to control your animation, and also view control, okay? Some zooming in and out, dolly camera or field of view, and so on, okay? Anyway, it's too much complicated, okay? This GUI, graphic user interface, has 2 complicated options, icons, buttons, menus. So that is why most people scared when they learn this kind of application at the beginning. That is why 90%, 99% students abandoned to learn about this kind of application. But I believe if you know just 10, 20% of this 3D Max, you can do anything what you want to do, okay? So let's take a look at, again, a little bit about interface, okay? This is graphical user interface, GUI. As you know, menu system, you always use this kind of interface. Icons, toolbars, also kind of representative GUI interface. And tapped grouped icons, toolbars, so-called ribbon interface, developed by Microsoft. Okay, Microsoft most of you and me, we use Microsoft Windows system, okay, Windows 7, Windows 10, whatever. Microsoft is the developer for operating system. So they provide some fundamental schema for application development. So this kind of interface mechanism developed by Microsoft, not Autodesk or not some software vendors. That is why he recently developed software are similar looking to Microsoft applications such as Office, okay? Anyway, typing, clicking, mouse, drag and drop, keyboard stroke, they are GUI-based interface things, okay? So that is GUI, okay? Graphical user interface. Most Windows applications and Macintosh interface. Nowadays, you are using GUI mostly. But actually, before GUI, command line interface, and still some of them available, okay? Command line interface. And also, as you are aware of or not, NUI, natural user interface, is very common today. You know how to touch your touch screen or your smartphone, motion recognition. Your smartphones have certain type of sensors to detect motion, your voice, okay, and learn about you, what your searching keyword, your machine learned what is your preference and so on, okay. Anyway, this is so-called NUI, which has direct and intuitive interface. GUI is kind of metaphor-based. Metaphor means some icons. Diskette icon means save the file, okay? T-pad icon means render in 3D Max, something like that. Codified strict, that's CLI, command line interface. So general software we use today, mostly in this category, GUI, NUI. But computer graphics, what if you want to create 300mm thickness wall object by using touch interface? It's not easy, okay? In that case, simply typing 300 in keyboard interface, that's fast, okay? That's why we are using some part of CLI, mostly based on GUI, okay? Simply because it should be efficient and in precision, okay? So AutoCAD command line or some other applications are using such interface. Why 3D graphics applications are hard to learn? Think about 3D object. If you want to design something like this object in curvy shape, if you design front view, right view, and top view, bottom view, whatever it is, they are all 2D projected on this kind of screen, okay? If you rotate, zooming in and out, that's one type of viewing, but not actually in 3D. This one should be in 3D world, okay? So what if you can create this kind of object in 3D world using 3D magic wand? You can draw something in 3D, okay? By using computer interface, not 2D modeling like this one, okay? Right view, front view, top view, whatever. So 3D laser scan is representative option for modeling 3D in real 3D world. Image processing, so-called photogrammetry, also available technology nowadays. From 2D pictures to 3D model. Something beyond keyboard and mouse, okay? That is kind of NUI based and something advanced from GUI. When you use GUI, you have to control 3D object in 2D screen, okay? So something tangible devices for manipulating 3D objects in 3D way. That is ideal, okay? This is ideal 3D interface. But in reality, we use 3D graphics tools in GUI or partial CLI, handling 3D objects in 2D screen. To complicate 3D modeling on 2D projected views, okay, flat views, too many icons. You know which icon means what, okay? You have to figure out. Too complex option, too many functions. It's not easy to understand exactly what you need to do. So this is ideal, this is reality, okay? This gap makes you something really hard to learn 3D graphics, okay? But of course, there are something different and ideal interface. Take a look at this object named iSphere. If you push some part of this object, think about this is 3D mouse, okay? If you push this part, the geometry is going to be pushed, okay? Or if you pull the other side, this one going to be extruded, okay? In 3D, this is 3D object. 3D bricks, pebble, paddle, and a goggle, okay? Some virtual reality goggle or similar one, Oculus, whatever. And this kind of magic wand, you can directly model 3D object in 3D world, okay? Not on 2D screen, and so on. There are a bunch of examples. So let's take a look at something beyond GUI interface, 3D making tools, okay? They are something available. And today we're going to quickly review what kind of applications are available. So application example for 3D scan. The first one is 3D scan, two types, okay? First one is laser scan based. Second one is image based processing. So actually laser scanner usually really expensive, okay? But image based scanner, 100% of you already have image based scanner by using your smartphone, okay? Some applications you can install and you can use. I think some of you already used this one, photogrammetry based 3D generation method. And also laser scanner for space or object, two types of laser scan, okay? For space, we usually need a really expensive one, okay? I'm going to show you our example. But for object, our device room will lease you this object scanner for you for 1 hour for one time. Okay, laser scan first for spaces. This is typical laser scanner, and this is the mechanism, and this is kind of building scan example that I showed you before. They are geometry, but originally they are all the group of points, so-called point cloud. Millions, thousands, millions of points, okay? Why? Laser scan, there is laser, one single ray get one single point, and it detects the distance, the location, and then it can record that specific points, X, Y, Z coordinate system. That's it. So millions of points, group of points going to create this kind of geometry. So this is sort of very kind of frequently played my example, okay? This is a design school located at San Francisco, kind of handheld laser scan for environment, okay? Now it's building inside. Some people walking around, okay? Now it's the inside of this design school's building and going to get out of this building and so on. But actually this is series of laser scan, and it is a video it's kind of looking like walking around, but actually it's not walking around point cloud. It's kind of group of static point clouds. Anyway, this is one example. And let me show you this sort of advertisement video, okay? Okay, this is actually an advertisement. Faro is one of the leading companies in laser scan industry. So just 1.5 minutes, you need to take a look at the fundamental mechanism of laser scan, okay? Even if you have watched this or a similar video before, please take a look, okay?
Taking the world from 2D to 3D, Faro is a global technology company that develops portable 3D measurement and imaging solutions. Faro's commitment extends well beyond product performance and constant innovation. With Faro, you have 3D measurement peace of mind. The Faro Laser Scanner Focus 3D is a high-speed 3D scanner for the detailed measurement and documentation of large objects, spaces, and buildings. With a range of up to 120 meters, the Focus 3D creates photorealistic, three-dimensional images of reality. Thanks to its intuitive control concept with a touchscreen display, it's as easy to operate as a digital camera. The rotating laser of the scanner touches, in the truest sense of the word, its surroundings. The laser beam is used to measure the distance to the object and, together with the device's 2 rotation angle data, determines the coordinates in space. Several million of these 3D coordinates result in a complete 3-dimensional impression of its surroundings. Color scans are produced with the help of the integrated digital camera. The scan data is saved on the internal SD card, making it very user-friendly to transfer the data to a computer. Faro's Scene software automatically combines individual scans with the aid of integrated sensors in the Focus 3D, such as dual-axis compensator, height sensor, and compass, to create a cohesive point cloud.
The building industry is primarily developing towards the renovation of existing buildings for which plans and drawings need to be prepared. For this, laser scanning is the perfect tool.
Data acquisition by means of 3D laser scanning is faster and more reliable than conventional documentation methods. Whether for 3-dimensional building documentation, monument preservation, or forensic crime scene documentation, thanks to its simple operation and compact design, the Laser Scanner Focus 3D is ideally suited for a variety of applications. Reichenbach Architects in Hanover offers scanning services aided by professional hardware and software supplied by Faro.
Okay, I think that's enough. Okay, as you see, mechanism is sort of simple. Okay, laser detects one single point precisely, and it's going to be moving 360 degrees. And one slice of this plane going to be collected, and this one going to be another axis-based 360 degree, okay, in order to collect entire points for environment. So that is really powerful for existing building acquisition, geometry acquisition, for building reconstruction, remodeling, renovation, and so on, okay. This is the actual laser scanner. Its brand is Leica, one of the famous camera brand in old-fashioned or DSLR camera. Really expensive, but we borrowed this one for scanning this room and the first floor of this building, okay, lobby. So after getting the point cloud, this is our first floor, okay, our building first floor. Some people also scanned the ATM machine and chairs, elevator, space. That's the actual laser scan result. And as you see, this dark black means the location of laser scanner. And surroundings all scanned. But after scanning, we can change the view. We can see not only the position of the scanner, we can take a look, totally different view like this. Simply because this is 3D data, okay? And this is the external view of this first lobby of this building. And this is different view. You know where it is, okay? The kind of table, chairs, some rest area, close to the elevator space. Even the convenience store, 사군, also scanned by the laser, simply because penetrating laser through glass window, glass door, okay? So they are some examples for laser scan based. And let's take a look at some image based scanner, especially for object or space. The technology name is photogrammetry. And also there is usually hybrid ways we use. As you saw in the Pharaoh's laser scan video, this digital camera also embedded in that scanning device. But anyway, that is hybrid. Okay, usually laser scan and image-based processing available for that kind of device. Series of cameras. Okay, 2011 at Autodesk San Francisco office, when I was at this office, there is some prototype application. Thanks to this several camera, just sitting on this chair and simply click the button for making 3D like this, okay? So this application is now available in your computers. As I introduced you before, this is Autodesk application 1-3D Catch. But usually the prototype of this application was looking like this. What you need to do is taking pictures, series of pictures by using your smartphone, okay? Your phone camera. So here is the example. Let me show you the example video quickly. This app name is Autodesk 1-3D Catch. So you can download and simply install and take pictures, okay? Entirely triangular shape meshes, and you can edit. This is app version of your smartphone, and also there is a PC version, okay? Let me quickly show you the example, okay? This application named okay 1-3D Catch, this one, okay, this one. By using this app in your iPhone or Android phone, whatever it is, you can take a look some. At this time, let me quickly show you some last week's gallery. Okay, let's take a look this one. Kind of slow, but let me click cat. Probably the name of this production is cat, so it's going to be a cat, okay? Okay, it's slow, but anyway, now it's downloading. Okay, there is a cat image, okay? By using this touch interface, you can see, okay, this is the other side. Actually, this is the correct view, okay? So a cat is sleeping on a couch. So by using this phone inside of this app, what you need to do is taking series of pictures, and then you can generate this kind of 3D geometry. This geometry can be imported into your computer tools, 3D Max, SketchUp, whatever, by using specific application. This is surface-based 3D, of course, but it has anyway precisely generated texture. So this is one example of actual application for image-based scan. Okay, this 1 to 3D catch is Autodesk application that is available on your any type of smartphones. Similar to this, this is another example that I introduced you before, probably. As you know, Google Earth, Google Map, they already scanned our entire planet, okay? Building exterior. But nowadays, they have another plan, probably even advanced plans to explore entire building inside, okay? Interior of building. Now their concern is inside of the buildings. So this is one of their prototyping application they developed. Let's quickly take a look at this video again.
My name is Johnny Lee, and I work in the Advanced Technology and Projects Group at Google. Our small team here, based in California, has been working with universities, research labs, and industrial partners to harvest the last 10 years of research in robotics and computer vision to concentrate that technology into a very unique mobile phone. We are physical beings that live in a 3D world, yet mobile devices today assume that the physical world ends at the boundaries of the screen. Our goal is to give mobile devices a human-scale understanding of space and motion.
This is going to allow people to interact with their environment in just a fundamentally different way. We can prototype in a couple hours something that would take us months or even years before, because we didn't have this technology readily available.
What happens if you have all these pieces in a phone? How does that change what a phone is?
We have created a prototype phone containing highly customized hardware and software designed to allow the phone to track its motion in full 3D in real time as you hold it. These sensors make over 250,000 3D measurements every single second, updating the position and rotation of the phone, fusing this information into a single 3D model of the environment.
We have a problem called navigation indoors, and it's a solution to that problem.
It tracks your position as you go around the world, and it also makes a map of that.
Imagine that you scan a small section of your living room and then are able to generate a little game world in it. I don't know of any other controller or gaming device that can do that.
Putting all this together, they pulled in experts from all around the world and got them all working on the same project.
Those are very high caliber people. Why? It's very simple. I think actually people believe the vision. Localization and mapping is there on your phone, and you just use it. It's this ability to follow in other people's footsteps.
And we can also benefit from what we do for the project back for the open source community.
Use it for visually impaired, give them auditory cues on where they're going.
Being able to map your home, check out, let me see how this furniture looks in my room.
Virtual windows to sort of different worlds. I mean, the possibilities are really endless.
Over the next few months, we will be distributing dev kits to software developers to develop applications and algorithms on top of this platform. And we are just in the beginning, and we know there is a lot more work to do, but we are excited about where it is going to go. The future is awesome, and we believe we can build it faster together.
By this video, Google developers, they use MacBook, okay? Not Google notebook or computers. And also, by using these sensors, this kind of phone has a bunch of sensors, okay? In order to collect your indoor geometry, GPS is not available indoor, okay? GPS signal from satellites couldn't be penetrating concrete, so no signal indoor. So we are using Wi-Fi or some similar technologies, but this kind of devices, which is all available to anybody, is one of the solutions. That's kind of prototype of this kind of indoor geometry acquisition, okay? What you need to do is simply handheld this one or a similar one and moving around, that's it. And also there is another device, object scanner, okay, this one. I brought this one today just for your example, okay, this one. This is available for our department students. You can borrow this one from device room of our school. As you see, this one I scanned, okay, and I print this out using 3D printers we have, okay, this one. Let me show you this one if you want to see this one in detail, okay. Let me show you this one, okay. Let's take a look. Who's this? Okay, who's this? Okay, right. Okay, now I'm gonna scan you, okay. I'm gonna connect this one to my computer that is available software. You can use this one for actual use. Okay, volunteer. I'm gonna scan your face, volunteer. Okay, come over here with a chair, okay? I'm gonna create 3D geometry for you. I'm gonna let you know how to use this kind of application. So, okay. Hi. Just a second. Okay. Okay, let me open the application for this hardware. Okay, this 3D scanner. Okay, at this time, we can scan an object or a person, head. Okay. Okay. Come close. Come close. So, okay. Actually, if you want to scan your head, you need to get, okay, backside first, okay? Actually, this chair is not good. Usually, office chair has very well rotating chair. So this is laser scan and image scan base. So this, by using this application, you can easily acquire your geometry. Whatever it is, okay? It can be you, your friends, or a specific furniture, object, whatever, okay? So if I say you need to rotate by yourself, just a second, not now. Okay, start scan. Okay, now it's scanning, so turn left, okay. Slowly, and don't move your face. Okay, lost tracking, again, stop. Okay, moving your chair. Just a second. Okay, turn. Slowly, okay. 계속. Lost tracking. Okay. You need to learn how to do that, how to do this. Again. Okay, stop. Go back. Okay. Just a second. This is kind of failure. Okay, this is kind of failure. No. no front side, okay? No front side scanned, only back side. As you see, even if we took the back side, anyway, this is still 3D. So let me go home and again, try it again, okay? You need to rotating without any face movement, okay? Precisely in the same place, okay? Just a second, just a second. Click scan. Okay, turning slowly. 빨리 돌아. Okay. Move. Don't move your eyeballs. Don't say anything. Okay. Okay. Okay, turning. Okay. Click next. Let's see what happened. Okay. Okay. Now we can find out 3D geometry. Of course, there is some problem. That is kind of okay. Actually, even if you have some holes and some blank side and chin part blank, but that's okay. Let me click solidify, okay? If you click solidify, this blank surface is going to be filled with some appropriate geometry. So now this one has some solidified geometry, okay? So what we need to do is simply save or put this onto 3D printer in order to print out, okay? Let me show you this one example. Save file like this, and let me open that geometry. How about in, okay, this one, 3D printing application. Okay, import geometry, this one. Oh, not this one. Okay, it's not loaded again. Okay, here it is. Okay, some problem for geometry, creating geometry, but let me change the size of this one, 20%. Okay. Simply this cube box means 3D printing zone, okay? Your object should be placed inside of this box from bottom, and if you prepare to print, and then 3D printer will plan how to layer this structure in actual 3D. I'm going to let you know how to use 3D printers from your geometry, your own creation, not this one, or something like this one. You can import this geometry into 3D Max or something similar, 3D application. Anyway, this is one example of 3D geometry creation. But actually, there are more applications, more examples available for our actual design studio or some extra work, whatever. Take a look. This is picture, okay? And if you want to use this one for actual design for your wall structure or wall pattern, whatever, from physical object, what you need to do is taking pictures and get the geometry. This is 1-3D Catch PC version, okay? Not smartphone version. Smartphone is very good at acquiring those pictures, but some making progress, I mean some modification, even if smartphone has that functions, you can do that easily by using your computers, laptops. So that geometry can be acquired like this and imported into specific application and placed your design. This is an example, okay? What if this one is really complicated one from Rome, Paris, somewhere in Europe? When you visited some specific place, if you find very spectacular or really unique geometry, real object, what you need to do is taking pictures from this kind of applications, and then you can reuse it. Another simple example. And also image-based scan for space, okay? At this time, photogrammetry-based space scanning. How about this? This is aerial photography. Which one took this picture? This is actually Georgia Tech campus, and this is Atlanta, Midtown and downtown area, okay? As you see, this is a drone, okay? This one, this drone, okay? Not the drones for war. Anyway, this drone can take series of pictures. So flying over this university campus, Georgia Tech campus, and then we can get hundreds of high resolution pictures. Actually, the slides excerpt from Matthew Swartz's guest lecture series last early spring. Okay, thanks to Matt, I can show you those series of slides. Anyway, we can acquire amount of image-based pictures for that site. The site here means Georgia Tech campus, okay? And then we can some photogrammetry purposed geometric points, some sparse point cloud and dense point cloud points, okay? How about this? This point cloud from image-based scan, and now we can acquire triangular shape-based mesh, okay? In other words, thousands, millions of polygons for the geometry. So this geometry for the campus buildings can be easily acquired by drones and this kind of image view. Take a look, this one. The picture name on top of this location. This location means the flying path of the drone, okay? This is kind of GPS controlled. So you can plan the flights, okay, on top of specific site. That is why you can acquire this kind of building. So let's take a look at this actual geometry. This is Google Map, okay? As you know, Google Map supports this kind of creation. Let's take a look at where is this place, okay? This is the map view, and the state Georgia, and there is Atlanta, and middle of Atlanta there is Georgia Tech, okay? This is Georgia Tech campus, kind of really big campus. This campus, this one looks like exactly the map we have usually used through the website. But if you click Earth, this is Google Earth mode, okay? But actually now this one has 3D geometry. By clicking Control button, you can see this map in this 3D geometry. Unfortunately, Korea, Seoul, or most of our cities are not available in this kind of geometry creation. But all those geometry acquired by some image-based processing, GPS, or some satellite-based pictures and so on, okay? No need to create those geometry by using SketchUp or 3D Max, whatever, okay? So you can rotate the view, okay? This is Atlanta Midtown, downtown area, and Georgia Tech campus we visited before. Okay, so in this way, we can navigate 3D geometry like this way. So thanks to this kind of geometry acquisition technology, laser scan, image-based scan, photogrammetry, flying drones, and so on, we can get the geometry. Let me show you the example drone, okay? As you know, this is kind of toy drone, okay? Toy drone, and even this kind of toy drone can have some type of sensors, okay? Sensors. You can control the drone. If this one has some specific type of image mapping sensors, whatever, now the entire geometry inside of this room can be acquired, okay? Okay. Just $15, okay? $15 from direct shopping from, okay, some problem on one propeller. But I have 5 more these drones, okay? This one can be installed sensors or even small size pictures, whatever, okay? Okay, let's get back to the course material. Theories for today's 3D graphics. After learning, we have learned user interface issues and some additional ways of acquiring geometry, okay? But now we're going to get back to reality, okay? In our reality, no drones, no laser scans for your design, actually, okay? So we need to learn geometric modeling, 3D geometric modeling. As I showed you before, this is your geometry. You created a box object in SketchUp or 3D Max, Maya, Blender, whatever, okay? You have to know its subcomponents, okay? The subcomponent of this one listed here, vertices, edges, faces, polygons, surfaces. They are points in terms of geometry, lines, okay, polygons. So if you drag one of the vertices in this box, your geometry is going to be changed, okay? If you rotate this line, your box shape also going to be changed. That's what happened and what you learned in SketchUp. But actually in SketchUp, there is no point control, okay? But in 3D Max or even any other complicated 3D geometric modeler and visualization tools supports entire subcomponents control. So modeling 3D object means creating an object and never-ending modification. So think about that high-rise Lotte Tower you can see over that window. That building is totally looking different from this box, but originally you can create this one and you can modify until the shape is close to that building, okay? Create, modify, kind of never-ending, very recursive process. So according to this geometry control, this is 3D Max interface. Today we're going to deal with this one slightly. Editable poly, okay? Edit polygon. Editable poly has vertex, edge, border, polygon, element. So if you choose edge and then your interface is going to be changed for editing edges or vertices if you click vertex, okay? That's fundamental interface. If you click polygon or this one, polygon, you can push pull, okay? You can rotate, rescale, move. Whatever you do, your geometry is going to be modified by editing 2D geometry, which means sub-component of this 3D object, okay? Sub-components, they are all in 2D, okay? Not actual 3D. Anyway, making primitive, this is the fundamental way of your geometric creation. Very easy. Simply click sphere and click twice, and then you can generate this kind of thing. Kind of recursive modification against this object. You can create anything from this one, okay? Specifically, there is a teapot in 3D Max, okay? We used this one for example render, but this one actually not the primitive geometry, but defined in 3D Max, developed by Martin Newell. It's a kind of legendary Utah teapot, okay? Somewhere around the Utah area, this teapot was kind of common, okay? So this man were some ancestors in developing this kind of 3D geometry. They had tried to create this geometry, okay, using this Utah teapot. So as an homage for their early efforts, 3D Max has render icon by using this teapot, okay? And also this is one type of primitive, okay? Primitive geometry, predefined geometry in 3D Max. So amount of 3D primitive geometry you can easily create in that kind of 3D object. So standard primitives, extended primitives, including torus knot and a lot of modifiers defined in 3D Max. So creating primitives, we already have looked at this one. And today also we're going to look at this modifier, some of modifiers. From this box shape or teapot, you can modify by using editable poly or hundreds of powerful modifiers defined in 3D Max interface, okay? That's what we're going to use. So all they are primitives, okay? One single plane, 3 spheres, 1 teapot, and Autodesk material, and 3 lights, and just default black environment. But anyway, it looks like sort of photorealistic. But this one shows it's not an actual picture. This one proves that this is kind of computer graphics, okay? No one cannot make this one happen. Anyway, let's talk about the way of geometric creation in that kind of 3D tools. How many ways, how many methods, how many mechanisms you have? Around 5, okay? Not that many. No 100 ways, okay? Very simple. The first one, the first way, first mechanism is extrusion. You know this, okay? Push-pull in 3D, extrude in AutoCAD. So in 2D plane, there is 2D geometry. You can make that another axis, usually G-axis, extrusion, okay? This is the first fundamental way. This is 3D Max interface. You can draw anything else, okay, in top view, and you can make that 3D by using extrusion. Next one is revolving. Lathing, this term is actually the term in 3D Max, lathe, okay? But usually it's revolving. One axis, okay? Linear axis, and one single section profile. Simply revolve it, you can create this kind of object. think about this complicated 3D object. It looks complicated. If you create cylinder primitive and modify this one, it's gonna really time consuming. But what if you draw one single axis and section profile? Simply rotate modifier will create you that geometry. The third one is actually important. Sweep. Sweep, okay? Sweep means kind of cleaning or drawing. So there is a section profile and specific path. Sweeping followed by this path can generate this kind of geometry. So there is one section profile and another path, and then 90 degree, this one can generate this kind of path. There are amount of applications of this sweeping in actual 3D geometry making. Next semester, when you are creating some parametric model or building information model using Revit or Bazari, whatever, you can find out a lot more example cases, applications. Next one, some others, okay? This is kind of morph. 3 different type of sections, or even just 2, you can create this kind of thing, skinning. Another modifier defined in 3D Max. And also constructive solid geometry. Actually, 3D Max, SketchUp, AutoCAD, they are all surface-based 3D. But in solid geometry, you can easily create this kind of complicated shape using operations from primitive. This box union sphere generates this one, okay? And 3 unions, this is intersection, and this is union for 3 cylinders. And then this object minus this one. That's the final production, okay? In solid geometry, that kind of operation is kind of common and usually happened without any problem. But surface-based model, there is Boolean operation, but kind of error-prone, lots of errors, simply because it's surface-based 3D calculation. It's not that easy. But actually, in reality, for architectural design, architectural modeling, those are layers imported from this 2D CAD file, okay? That is why 2D CAD is still important for precision, for layouting, and some specific early phase of design. When you draw this kind of CAD files, CAD plans, you can directly import into 3D application and simply extrude them. And then you can create some 3D buildings, environment, okay? You have to take account dimensions, units, and so on. But thankfully, in 3D Max, there is parametric objects named AEC extended, okay? That has wall object, window object, stair object, even foliage object, and so on, related to architectural design. So this one is fundamental top view of that kind of 3D generated geometry, okay, from 2D CAD system, 2D CAD file. Extruded walls or just wall object modeled and stair object modeled, some windows, window object, and foliage. They are some 3D Max default trees, okay? 3D Max has 3. But eventually, you may need something like this kind of visualization, okay? Very typical visualization of 3D floor plan or some interior views. Actually, this one created by homestyler.com, not 3D Max or actual 3D modeler. But anyway, nowadays there are amount of available applications, software, visualization tools, modeling tools, and so on. So until you get this kind of high quality image, what you want, you need to create modify again and again. Okay, that's fundamental process. Okay, let's get back to 3D Max design. Learning 3D Max design and it's behind the mechanism. It doesn't mean that just learning interface. Okay, we have learned 3D Max interface really complicated. But if you understand the background theories behind the technologies, mechanisms for that, you don't need to learn again and again. When 3D Max design newer version released or some different type of application you want to learn. How about Rhino? Rhino has totally different GUI, totally different interface. But behind the technologies are almost same. Okay? If you understand some mechanisms, for example, if you know what is ray tracing and how it works for visualization, rendering, if you know what is bump map, shading, Bezier curve, Knobs curve, what is UVW, what is sweeping, polygon, mesh, lathing, something about camera and lenses, if you can figure out some fundamental issues in this area, you don't need to learn some detailed part. What you need to know is its interface, okay, by YouTube or web tutorial. Just 1, 2, 3 hours enough. And then you can learn any kind of different complicated 3D geometric tools. Without understanding what are these, learning 3D Max is equivalent to memorizing the order of clicking sequence, okay? Which icon means what? What to click for doing this? Memorizing such interface things is kind of very primitive level. It's nothing. If you understand the logic rather than the order of clicking sequence, you can learn any complicated 3D modeling and rendering software, such as Rhino, Maya, Blender, or even Beam Tool, Revit, and so on, okay? Including 3D Max. That's my point, okay? So let me show you some 3D Max specific geometric modeling and rendering issues briefly. What we need to do by using 3D Max or 3D applications. Simply two things, okay? Modeling. The term modeling this semester means geometric modeling, okay? Not information modeling or even building information modeling. Just create object and modify the object. That's the first reason. Secondly, visualize your scenes, so-called rendering, okay? Also animation or something applications. It is kind of series of rendering, okay? 30 renders for 1 second. So that is kind of subset of rendering. Same to number 2. So only two things we have. Modeling takes time simply because you need to modify again and again. Rendering, many things you need to know, okay? Some techniques, skill dependent. Animation, lots of things on the rendering, but it's hardware dependent because I told you 30 rendering for 1 second. So what if you want a 10 seconds animation? 300 renders. If one takes 1 minute, 300 minutes you need. So you need to know some performance, how to use cloud computing, backburners, or how to save your time for render, and so on, you need. On the geometric modeling, first thing, create 2D geometry and extrude, lace, revolve, sweep for making 3D. Import your predefined 2D or even 3D from warehouse, whatever, okay? And manage. Manage means modify, never ending, recursive, time consuming, okay? Under visualization, under the rendering, assign material, add lights, add camera, render option control, and render scenes again and again. So we have learned this part. Also today we're going to add artificial lights using mental ray and controlling camera and so on. We're going to learn those sub-components in the rest of this semester, okay? So this single slide means almost everything about 3D graphics tools. And also this one, this page will show you use scenario for interior architecture design for you guys, okay? How to use 3D Max, that's the question, and this one is kind of one single page answer. Define UOD, universe of this course. What's in your mind? Roughly freehand sketch or write down on your notebook. That is kind of preliminary definition of your world, okay? Your universe of this course. If you are in charge of designing commercial space such as Nike brand shop in front of our university, Hanyang University, you don't need to bring Volkswagen, Hyundai Motors, or even totally different things such as Shrek. You don't need model Cinderella, okay? If you are working with your own universe, you have to define your universe and its discourse first. And create geometry, modeling. Firstly, your environment, okay? Even if it's a box, that's okay. You don't need to create the entire building if you are in charge of just one single space. And your modeling design target, design element. On the environment, there are planes, walls, sky, outside view, modification, recursive modification until your environment just created. Also 2D sketch file, 3D modeling, import given geometry, existing geometry, modify again and again. That is geometric modeling. And then visualize, okay? Material, lights, camera, render options. That is not the end. If you don't like your output render, you go back, environment control, modeling geometry, again and again until you get your image, what you want. And some retouch in 2D graphics tools such as Photoshop or PowerPoint or any type of presentation applications. So sometimes retouch by Photoshop much easier and convenient than creating everything in 3D geometric tools, okay? So this is simplified use scenario. But this simple process, you have to plan your world and iterative process for making your final design, okay? So now we have learned some features, but we're gonna learn rest of others in this semester. Some more user scenario, okay? UOD, defining UOD first, and geometric modeling, some tips and rendering tips, and some retouch for your final visualization, and so on. So this page also shows you some additional scenario for interior architecture design. As I show you today, this is 3D Max 2015 interface. There is Cartesian coordinate system. Looks like 2D, but actually this is also 3D, okay? Entire viewports are 3D, but looks like 2D. Anyway, 3D Cartesian coordinate system, view cube, you can rotate this view cube by simple click. Also workspaces, you can model here, and steering wheel. There are lots of hotkeys, okay? So I told you some hotkeys, Alt-W, F10, or Shift-Q, rendering, and object handling, QWERH, Control A, spacebar, and so on. Okay, so at least those hotkeys should be very well known to you guys when you are doing something in 3D Max interface. Okay, and also there are lots of more hotkeys, and you can set up your own customized interface. Totally changed interface from default, but you don't need to change the interface. The computer is shared by other friends, so we can use some simple default interface using those default hotkeys and the basic interface things. Okay. Okay, let's move to the lab exercise. Okay, quickly. We need to move on lab exercise number 1 first.